All right. Welcome everybody to this Friday Brown Bag. Um, Virtual Coffee well, you guys are all Virtual Coffee members. Our Virtual Coffee's mission is to be a welcoming tech community that allows room for growth and mentorship at all levels, and to create a meaningful opportunities for learning, leadership, and contribution for everyone. Um, we have a code of conduct at Virtual Coffee that we take pretty seriously. I'm going to paste the link in here. And we expect participants and speakers to please abide by it. Our Brown Bag series is pretty cool. It's member-led, organized, series of sort of informal lunchtime talks about pretty much whatever you like. We've had we've had a ton of them. They've ranged all from all sorts of different topics. We have a form for if you'd like to give a brown bag talk. Put the link in there for that too. So open to any of our members, obviously. If you have anything you'd like to talk about, it doesn't even have to be tech related at all. Please feel free to fill it out and we'll kind of get going from there. Let's see. We have a couple of ones coming up aside from our normal coffees. We have, I have a list here. We have on March 29th, which I think is Monday, maybe. Probably should have, yeah, Monday. Rahat is doing a talk on cognitive behavioral therapy for imposter syndrome and career advancement, which will be very cool. On April 2nd, well, I have the title. We have debugging. Oh, that's Nick. On April 2nd, we have debugging JavaScript and front end with Nick Taylor. And on April 16th, we have a guide to public speaking and presentations, which is possibly Gant. sorry to Gant or whoever it is that is doing that talk. I didn't write down who it was. So anyway, we got some cool stuff coming up. Today, though, we have Kirk Shillingford, community maintainer of Virtual Coffee and all around awesome person. He is going to be talking to us about TypeScript and with regards to making your app awesome. I think it's React. Is it other than React or is it just React? Doesn't matter. You'll tell us. Sorry. Leveraging types with TypeScript. So I'm going to let him tell you all of that. During the talk, please you can feel free to throw questions in chat and I'll keep an eye on it and convey them to Kirk. And I'm sure Kirk will open up for questions at the end. But during the talk, yeah, just dump them into chat and I'll kind of keep them updated. And other than that, I think I'm going to turn it over to Kirk. So thank you so much, Kirk, for coming, and I'm excited to hear what you have to show us.
Hey, everybody. Okay, so step one, let's see if I can share my screen. No ducks will be harmed in giving this presentation, Charles. That's going to take a while. Can you guys see the thing?
Yes.
Okay, cool. I can't see you all at all. So, feel free to do kind of audio confirmation. Okay. Hi, everybody. My name is Kirk. This is going to be type-driven development with TypeScript or domain-driven development or leveraging types, using types. Like, why did we even make this thing called TypeScript? What's the difference in JavaScript? If you're going to be writing TypeScript, like what are the advantages there? All that good stuff. Okay, so who am I? Why am I even giving this talk? Is something we should probably establish from the beginning. Like I said, my name is Kirk Shillingford. I live in the Caribbean. Live on the small tropical island of Dominica. It's raining today. It's been raining all week. It's not like the sunny paradise like normal. That is pretty cool. I've been doing some kind of programming for about 7 years now because it was more fun than the traditional engineering I was going towards before. I've been doing functional programming for about 5 years. If you've met me in any capacity, you know that I like functional programming because I don't shut up about it. It's very annoying. But yeah, I got into it relatively early in my career after doing lots of Python and VBA for a pretty long time, and kind of like it a lot. And yeah, I'm mildly obsessed with type systems. Just I'm really interested in the way different programming languages think and the sort of the different layers of abstraction. And I've spent a lot of time, too much time working on that and thinking about that and trying different things. So, it's kind of felt like it's a good time to share some insights about it, I guess. But yeah, what is this talk about? Many people see TypeScript as annoying or JavaScript, especially I think a lot of the more seasoned JavaScript developers, now that TypeScript is here and TypeScript is here, it's like, well, what is the point? Like, does this, is this actually helping me? This feels like a lot more work. But I'm gonna sort of take a look at, well, what are the features of TypeScript that really sort of do distinguish it from JavaScript and make it not just be like JavaScript, but like with more code. So we're gonna look at how to make the code safer, clearer, less boilerplate, and a better documentation. That last one isn't in italics, and that's going to bother me for years. Okay. So ultimately, I mean, brown bags are about, just sharing stuff you're into, and I just want to share the way I like to code. We do code challenges in VC every 2 weeks. Shout out to Mike in chat for leading the charge on that. And a lot of times when we do the code challenges, I write code in a particular style, and a lot of people ask me questions like, why'd you do it this way? And this talk will also kind of address that, like, how do you go from problem to solution? So let's jump into it. Let's do some framing. So what are our order of operations for today? First, we're going to do some clearing up of confusion. What is TypeScript? What the hell is type, and how do types come together? Then we're going to look at some of the tools in TypeScript's tool belt. We're going to look at type aliases, branded types, union types, intersections. I will explain what these things mean, and like how we use them and what the difference is from JavaScript and what they're like super helpful. And finally, we will look at a couple like working, living examples of using types and how you would use them in a typical application. Just these kind of like small snippets, but hopefully they provide enough context for all the nonsense that I'm saying. Cool. Part one, clearing up confusion. What is TypeScript? So let's just establish that. TypeScript is a programming language developed and maintained by Microsoft. That's kind of important in the sense that TypeScript's not going anywhere. Microsoft has been working on this for like 10 years. Visual Studio Code and TypeScript development kind of happened in tandem. So like there's a lot going on there behind the scenes. I think VS Code right now is majority written in TypeScript. Yeah, and it's a language that they sort of invented to address some of the design patterns and issues and concerns they saw with doing development in the browser, especially like with JavaScript. TypeScript is what we call a strict syntactical superset of JavaScript. She sells seashells by the seashore. And that's just a fancy way of saying that all valid JavaScript syntax is valid TypeScript syntax. So like a big thing for people getting in, it's like, well, I don't know TypeScript. I was like, well, if you know JavaScript, you can write TypeScript, So we have this function here, typical add function, you've seen it a million times. Is this JavaScript or TypeScript? Yes. It just, if this is in a JS file, then it's JavaScript. If it's in a TS file, then it's TypeScript, right? Because again, anything you can write in JavaScript, TypeScript will accept and say like, oh yeah, this is valid. This works. TypeScript transcompiles to JavaScript. So transcompiles is a nonsense word that like programmers have invented. Normally, when we say compile, we mean like high-level language to low-level language. Transcompile or transpile just means like high-level language to another high-level language. So instead of TypeScript being compiled to like bytecode or even like C or something like that, you put TypeScript in, JavaScript comes out, your browser never sees TypeScript, right? It's just, it only understands JavaScript. So by the time it like actually gets run, it's just JavaScript. Because of that, TypeScript can be compiled to older and newer versions of JS, not VS. So you can target like different systems the way you want. And many things in TypeScript have no JS equivalent, right? So like all valid JavaScript is valid TypeScript. That does not go in reverse. All valid TypeScript is not valid JavaScript. But that's just something to kind of keep in mind. Cool. What is a type? This is kind of a strange thing to say because it feels like a thing that should be obvious, but it's not. Like we talk about like data types and data structures a lot in programming, but we kind of never really establish what they are. A type is just a set of things. Yeah, there are a couple of memes in this I couldn't resist. And when I say set, I mean literally set in sort of like the mathematical term, like a collection of items, you know? And just to kind of concretize that, we're going to go through like a couple of the standard JavaScript types. The first one is void, also known as undefined. So this is a set with like a single value. Typically, you see it as void or two parens or undefined, or some languages use unit. There's only one thing in this set, like it's just void. There's only one valid version of this. It's just that. It can't be anything else. So the thing you'll see a lot in programming languages, especially like JavaScript, Python, is you can have a function that doesn't return anything, or we say it doesn't return anything. But that's not actually the case. Like all functions return something. It's just that when functions return void, there's a little like the compiler or the runtime understands like I should just ignore whatever this outputs because it's just void. It doesn't carry any information, so you can just like discard it. So like this function side effect, we're logging something to the screen, we're not passing anything back. So this function is actually returning void at the end, but like nobody cares. Boolean is the next step up. Booleans are great. Boolean, it's a set of two values, true and false. That's all Booleans can ever be. Like it's either this thing is true or this thing's false. It's one or the other. It's like the binary set, if you want to think about it like that. And it's pretty important for programming to have things be either true or false. It turns out like everything we've ever done is kind of built up at the end of the day on like true or falses. This function is a bad example because like, can Nickelback be anything but good and true? I don't really think so, but you know. But yeah, we can return Booleans and we use them for validation. We use them for a bunch of things, usually for validation, like is this right or wrong? Is this statement that we made logical or illogical? Cool. Number, okay, now it gets interesting. So number is a set of real numbers between, and don't quote me on this, JavaScript types, there's a lot of like approximatelys there, but just about between like negative 1.8 times 10 to the 308 and then the positive version of that. So this is a big set. Like this is it. I can't write out this set. It's not unenumerable, but it would take you like till the end of time to actually write out all these numbers. Yeah, and I mean that's, so we went from like unit having 1 and then Boolean having 2 to number now having like a bajillion. And then the last one I kind of want to go over from the basic types or the primitive types is string. The type string is the set of sequences of Unicode characters, right? So it's a set and each value in it is a sequence of Unicode characters. There are about 143,000 Unicode characters, and a string can be up to like 2 to the 51 characters long. So there are a lot of like valid strings. All these things are valid strings, right? Like emojis, like everything you can. Dave, just to kind of give you an example of like the span of what we're talking about here. It's not just like alphanumeric or even textual characters, like all of that kind of gets encompassed there. So these are what we call the primitive types. They can't be like broken down any further in JS. This is like everything we sort of make is on these primitive types. You can combine them though. Primitive types can be combined, and we can make like more nuanced, complex types. So here, this is like a JavaScript object, person, it's got a name, age, loves Nickelback. They keep coming up, I don't know why. So there's a question here, right? Like, so how many unique versions of this person record are there? And the answer is to figure out how many, like if, and it's, they're basically going back to what we said, like every type is a set of things. Like in the set of persons, how many different types of persons could we have? And the answer is, well, it's the amount of different types of each of its primitive values multiplied by each other. So it's like every possible valid string multiplied by like every possible valid number multiplied by every possible Boolean. So the answer is somewhere about this. I may have done the math wrong, but like the point is that when you have objects like this with different fields, every new field and every new data type causes like you have to, that's more and more ways you can combine them, and that's more and more types in your set, which is good, but can also cause problems. Okay, so here's an example. We have this thing called a tab status. We made this object tab status. It's got two fields, enabled Boolean, selected Boolean. This obviously, or maybe not obviously, but this represents like a tab in a typical application that you can click. And the idea is, hey, if the tab's enabled, you can click it, and then it's selected, and then you can like deselect it. So question, how many values can this button or this tab have? Well, let's see. It's a Boolean and a Boolean, and we just said that when you have objects with multiple fields, to get all their valid permutations, you have to multiply those together, right? So first way this could be, well, enabled could be true and selected could be true. Sure. Enabled could be true and selected could be false. Cool, makes sense to me. Enabled could be false and selected could be false. Sure, yeah. Wait a minute, enabled could be false and selected could be true. So you may or may not have noticed this, but one of these things is not like the other. The last one doesn't actually make any sense. And this is kind of like the crux of this entire talk in a way. We've made this thing in our program. We put this thing in our application. We have this thing called tab status, enabled, selected. And I'm like, hey, this is good. This represents what I'm trying to do on this page. But this data structure has a state like doesn't actually make sense. It doesn't actually map to the reality that we're trying to do. Like as programmers, we are trying to create meaningful abstractions. Right? The reason why we have all these structures, these classes, these types, these functions, these variables, is to have like meaningful abstractions so we can accurately represent some model that we're trying to work with. But this data type doesn't do that very well because this state is wrong. Like this state should not ever exist in our working application. But our data type allows it. And if our data type allows it, that means that our code, like we can never, it's never going to warn us if we try and do something like this, right? Like the compiler will never tell you like, hey, this might be wrong. Your linter won't tell you like, hey, this might be wrong, because it's a valid version of this data type. It's a valid version in the set of like tab statuses. So that's a little dangerous. Here's another one, right? So here's our person again, and we've constructed a person here, and this says loves Nickelback. It's false. Like this is clearly wrong. Also, the age doesn't make sense, the name doesn't make sense, but mainly the Nickelback thing. But it's the same thing as what we said before, right? Like we've said a person is a string, a number, and a Boolean, but like people aren't strings and numbers and Booleans. Like a name, most like names are in strings, but like not all strings are names, and like most numbers can't be represented as an age. Like an age is like typically between like 0 and like 200, which is, I don't know, 0. Like that's such a small set compared to the amount of numbers. So again, we're in this state where like we have this type, and we're using it to model some real life construct, in this case, like a person. But the fields in the type, the data types that we're using just don't map very well. And this is kind of how we get errors in code, right? This is how we get errors in code, where we're using particular structures and then we run it and like, hey, that didn't do what I expected. And then we check the values like, oh, that doesn't make any sense. Like that can't be that, you know? But like we didn't tell the code that. The code has no way of knowing in this instance, like, you know, age is not just a number. I love that joke so much. I'm really proud of myself. You know, but like it doesn't know that like name is not just a string. We didn't tell it that, so it can't stop us. And this is how like errors happen. You know, this is how you can like mistype things or misspell things, and they'll just go through. You know, and you don't find out until you actually run your code, which is dangerous. Like runtime errors are bad and logic errors are bad, and the reason they happen is a lot of times because we get into these invalid states. So primitive types like strings, numbers, void, they're powerful and they're useful and we need them, but very rarely are they actually good models for the domains our code are trying to represent. Like real life is just more complex and nuanced. Most things in life are not numbers, and most things in life are not strings. So we shouldn't use numbers and strings for everything we're trying to do. So how do we like solve this? How do we prevent invalid states?
Hey, Kirk,
Lots of ways.
real
Hey.
quick, we have a question if that don't mean to.
Oh yeah, go for it.
A good time. We were looking at the if you go back a slide or two, we were looking at those Boolean, the types that contain Booleans, and there was some questions about like so in JavaScript or whatever, something could be null. You know, you got to check for it. So like, could enabled be null? Is one question. You know.
Yeah,
Right.
no, that's a good question. So the answer is in TypeScript, no. In TypeScript, well, the TypeScript compiler is pretty flexible and it gives you a lot of options. But one of the options you will see most people use with TypeScript, it says implicit nulls off. And that means this cannot ever, like, if you say this can be Booleans, you can't pass null into this. Or if you try to pass null into it, you get a compiler error because you said it's a Boolean. Like this is either true or false. And that's like all it can be. So for the purposes of TypeScript, no, this cannot ever be null.
And then a similar just question, and it's possible you're going to get to this, so that like that is fine. But it was just about option, like how do you make optional ones, or how you add, you know, could you like, how would it look if you wanted enable to allow null in this situation, you know, or like if enabled could be optional, that kind of thing. Travis said you're probably going to get to that in a little bit, so I don't.
I mean, yeah. Short answer is there's a nice syntax sugar if you add a question mark to any field name in TypeScript, like enabled question mark, then it will understand like, oh, this could be Boolean or null. Like that's just it's a quick way of making stuff optional. But you have to be explicit about that, right? So you have to like tell it explicitly, I want this to be Boolean or null. You can't like you won't get it as default.
Makes sense.
Yeah, but we will also cover like a couple of those situations too. So yeah, thanks. Those are definitely good questions. I appreciate it. Yeah, if you have at any point in time, if what I'm saying is like not jiving, just drop it in the Slack chat. I'd be happy to clarify. Yeah, so the types are powerful, but they're not actually very good models. Yeah, so how do we prevent like these bad states? Like how do we prevent like these weird cases where our data is not in a shape that makes sense in real life, but you know the code can't tell? We have validation, right? We have if statements and checks on these. We have unit testing. Like I said, we have like if statements and like while and these different like logical checks. And most importantly, we have squinting at the code really hard, which is probably every developer's like number one go-to. Like, oh, this isn't working. Then you just kind of like squint until the answer comes to you, or maybe not. And these are great, like these are great and they work. And this is not a talk that says don't do these things. You should absolutely do these things. But there are other techniques, right? If only there was a way to make more accurate data structures that could make these impossible states impossible. And if only there was like a brown bag to tell you about it. Conveniently, that's what's happening right now. So part 2, TypeScript tools in our tool belt. Okay, so that was like the preamble, just kind of get us set up for what we're trying to do here. Now, I'm just going to show you some of the actual TypeScript things that can help you avoid the situations that we just like kind of described, and with help with a bunch of other things as well. So let's jump into it. Cool. So first, we sort of need like something to play around with. I have made this glorious pyramid of volume function. I love it so much. It calculates the volume of a pyramid. You pass in a length, a width, a height, and it returns the volume. And we have these type, like we've typed all our parameters and our return type, right? Like it takes length as a number, width as a number, height as a number, it returns a number. And this function is fine, right? In the sense of like this function works. It's pretty clear what it does. Everything's sort of like, you know, we have meaningful variable names. There's nothing wrong with this function. But this function, there's a couple things that we can do here that like might be appealing. And I use pyramid volume as an example, but think of like any function or any calculation that requires like a large number of moving pieces. And you're sort of like wondering like, what would you do here? Like the problem is, or one of the issues is like, at the end of the day, this just says, hey, give me a number, and I give you back a number. And that actually doesn't tell us very much. We have to like literally read the parameters to figure out what's going on. Step 1, type aliases. The simplest thing you can do in TypeScript is to like add clarity is the type alias. Type alias is just an alternate name for an existing type, but it lets you provide like more semantic meaning. So the first thing we can do here is just like, hey, you know, let's make these types called width, length, height, and volume. These are aliases for the actual, these are just like aliases, right? They're just like alternate names. But what we can do now is for our function, instead of saying, hey, give me a number, and I give you back a number, we can say like, hey, if you give me a length and a width and a height, I would like a volume. And we've moved the context for this function from parameter names, which may or may not be available depending on like where you're calling this, to type names, right? And it's like clear at the top of your file, like, hey, what's going on here? Well, there's, you know, like this, we've shifted the semantics to something a bit more structured, and we can use this in multiple places on an application, and we don't have to rely on like the parameter names anymore. In fact, I shrunk the parameter names, and we tend to hear this, right? Use meaningful variable names. But here, like we've still kind of done that, because as soon as you see this function, you know exactly what these things are, because the type is telling you, not the function, not the parameter name. There's a couple of nice things about this. So when you're using this in TypeScript, like it will show you these things when you do like when you hover over the function, so it'll like give you like nice context. And it's in the spirit of code as documentation. My argument is that this is slightly better documentation than this. Whereas if I see this in a file, like it's much quicker for me to understand what's going on than if I see this, because I get the type info first, and then I just see a function that's like working with that type info. I'm like, okay, hey, that's pretty good. So type aliases are good for that. They're good for clarity. They're good for context. The weakness of a type alias is that type aliases ultimately don't change anything. It's just an alias for an int. You still pass ints into this, or numbers, or you know, something like that. You still like pass them in, and it still returns like a number out. The compiler doesn't really, it still understands that these are just like numbers. So is there a way we can make this even more safe? Branded types. Branded types are a common technique in TypeScript of wrapping a primitive type in an object. So basically, we're using type aliases for objects, and we're like making this construct. So instead of just being an alias, like width is an actual object, right? It's got to be, we say like, hey, let's do a field called type, and we'll call it width, and let's do a field called value, and we'll call it the integer. And we can do this for all three. And our function looks the same, but this thing is no longer taking just regular integers. It is now taking these objects. And this gives us a ton of advantages. First, you can't just like accidentally pass into this function, right? That you have to turn them into the proper data structures. Second, you can never mix these things up. You can never accidentally pass a width into the first parameter or like a height into the second parameter. It says like, hey, I want a length and a width and then a height. If you give it the wrong ones, the compiler will tell you like, hey, no, you cannot do this. Also, you notice here, we're defining a type, but here we're just like giving it like a definite string, which is something that's kind of unique to TypeScript. Like if you can give it just like a single string and tell like, hey, this is a type, and it'll understand like, oh yeah, that's a type. And like you can use that in certain places. And if you try and pass something else, it'll get very upset. So you can't make, if you making a width, the only way to make a width is to actually use this string. You can't like pass in another thing. So that's like super powerful. And this is just like a really lightweight way, and like we've just done a ton of validation, right? So we no longer have to test to make sure like if we're using this, we're passing them in the right way. It's just like it's all kind of defined for us. We still have a ton of context, maybe even more context than before, because for each one of these, it'll tell you like, hey, this is the length and it has a value, and it's just like a more powerful way of ensuring that your functions actually do what they're supposed to do in the way that they're supposed to do it. And you're moving the effort of making sure that you did the right thing from your brain to the compiler, because now it's tracking whether you did this right, and it will tell you if you did it wrong, which is super cool. Union types, these are my favorites. Union types allow you to create a series of values to choose from. So like union types are like, they call them sum types, or like up ors, like it's this or that. So here we've made this type virtual coffee event, and we said, hey, it's a brown bag, or a lightning talk, or a coffee soon. These types just mean like or. And now we have this function announce. Announce doesn't take a string. Announce takes a virtual coffee event and it logs it to the console or whatever. But the key thing is, if I try and pass any string that is not a virtual coffee event, this will throw an error, right? Because we've defined exactly what virtual coffee events are. If I misspell any of these, it'll also throw an error, which is great. So yeah, the compiler complained. You will get type hints. So the fact that we've said this is a virtual coffee event, when we're actually trying to do anything inside the function, it understands like, oh, there's 3 values for this type, and it'll give us like hints like, hey, do you want to say brown bag? Do you want to say lightning talk? Do you want to say coffee soon? Which is great because we don't have to like remember what we're calling things. We've defined it here and we can just use them all over the place. And yeah, if you misspell the values, you will get a warning. I don't know about you, but a significant amount of my blood pressure spikes in life have been from having a problem and spending a ton of time debugging, only to find out like I misspelled something, or I had a capital where it should have been single, and like all these other silly things that it's frustrating to like lose so much time on in our development. Union types let you avoid that, and that's really great. And you can define these literal types like anywhere you want, and you can be very specific in the things that you need, and they're just like a very powerful thing. I like them a lot. These are probably like my favorite types. I use them everywhere because very often I don't need all the strings in the world. I don't want a function to accept all the strings in the world. I want it to accept like a few very specific ones. So I'm just going to make a type that has the specific things I want to accept in this function and nothing else. And that's great.
Kirk, oh, sorry.
Yes.
I
Go for it.
thought you were going to move off of union. We have several questions on the union.
Yeah, let's do it.
So Carolyn was asking, how are they different from literals, from literal types, just in general?
Oh, okay. I will. That's actually one slide over.
Okay, if the answer to any of this is it's coming, that's perfectly fine answer.
Yeah.
Excuse me. is Colin asks, is type as used in the object keyword? I think this was on the slide before this. Is it like a keyword in the language of TypeScript? Does it have to
Yes,
be a string, et cetera,
type
like that kind of thing?
type is the keyword in the language.
Specifically as used in the object where you had width type and length type a few slides back.
Oh no, I made that choice. Yeah, so these are just regular objects attributes. You can call it whatever you want. It's just like common practice when you make these types of branded types to call it type, because inevitably when you're doing this type of pattern, like you want like the first thing to say like what it is. Yeah, but this isn't. Yeah, it's not baked in.
Okay.
This one on the left is, but not the one on the right. Yeah, that's a good question.
So the compiler doesn't force it to be types that you
No.
defined or anything like that. It's just
Yeah, no. You could call it name. You could call it whatever you want. Yeah.
And then I guess I probably you're going to answer all of this on the next slide, but we had questions like sort of the same, or not similar questions of whether you can mix union types or nest union types. So
We are about to see that.
yeah, so I was going to say I'm pretty sure I saw on the next one. So
yeah. Okay. This is exciting. Also, again, I literally can't see anyone, so I didn't know if you were all listening or not. But this is good. Thank you. Okay. So union cases or union types don't have to be the same type of thing. You can mix and match as needed. Now, remember earlier on where we did that tab status? So let's do another version of tab status, right? But this time, type tab status is disabled or an enabled tab. And the type enabled tab is selected or unselected. So back to our question, how many valid states does this tab status have? And you may have noticed this one has 3, right? Because it can be disabled, in which case it's just disabled, or it can be enabled. But if it is enabled, it can be selected or unselected. So that pesky instance that didn't make any sense is now gone, right? This is actually the representation that we want of tab status. And this way, like you can never be in an invalid state in your application because tab status can only be these things, right? So remember, we're dealing with in a language that does not have the implicit nulls. So tab status will always be either disabled or enabled. And if it's enabled, it's always going to be either selected or unselected, right? So no more bools, no nulls. We've just defined like what is valid tab status. And this is kind of great, you know? And the nice part about it too is that these are all like words that have meaning to humans. So when you're looking at it, you're not seeing like a bool and wondering, I don't know what this bool means. Or, you know, it's just like disabled, selected, unselected. And that's really great. So yeah, union types are awesome. They're so good. The last type I want to show you before we kind of get into the practical examples is intersection types. Intersection types let us combine other types together. So here's the start. So we have this type user data, name, age, email, cool. Then we have what are the roles and permissions. So we have another type alias for an object, standard privileges. We have some privileges, key value pairs. Then we have admin privileges, which are, you know, a similar structure. We can intersect these types to make new ones, and they will have the combined properties of both. So here our type user is user data and standard privileges. And our type admin is a user and admin privileges, right? And we could have done this without the types, but here it's super clear what user and admin are. And with admin, we didn't have to repeat ourselves with the user, right? Like we just stacked on the things that we need. So intersection types are great. This is another good example of like code as documentation, because if you're showing this to someone, it's very easy for them to like read this and understand what's going on. With these situations, like you can even sometimes show this to non-technical people and it still like reads pretty well. They can still be like, oh yeah, this looks right, or this doesn't look right, and kind of get into it. So it's another great way of accurately like making your data structures actually match the domain that you're working in this like nice composable way. And that's super cool because depending on where you are in your application, you just need the standard privileges or you just need the admin user data. So that's cool. Putting them all together, right? So we can combine everything we just talked about, aliases, unions, intersections, branded types, to make exactly what we want stuff to look like. So here is a good example, one of my favorite examples. We're doing a landing page for web application. So we start, type landing page. I need some general page data and I need a user status. What is general page data? Everything, you know, all the stuff that's always there. I need a viewport, which is a tuple, length and width. I need, whether it's start mode or not, you put all your stuff there. User status. Well, what can a user be? Well, either the user's not signed in, or they're logged out, or they're a logged in user. But what does a logged in user need? Well, they need a username and an avatar, and you see what we're doing here, right? Only this, like, things that are needed in a particular state are in that particular state. And if they're not needed in that state, they're just not there. So when you transition your user status from logged in user to logged out, you don't have to worry about like resetting values or like turning things back to false or setting things to null, because this is all gone. That's not in this data, in the logged out data structure. Logged out is just logged out. So you don't have to worry about like deallocating or resetting, or it just, in our model, it is not possible to both be logged out and still have concepts like usernames and avatar strings, because that just is not how real life works. Like if you're logged out, like those things are not there. So you should make data structures to like make it impossible for them to be there. And that's what we're doing here. So that's kind of cool.
Real quick, Kirk, what is the difference between not signed in and logged out? Question.
That's kind of up to you. So the way I see it, let's say you actually go to a page. What you might see on a page when you're not signed in, when you just happened on the page, might not be the same thing you see when you're logged out of the page. But let's say in your model, it's the same page, then yeah, you could just have one thing, not signed in or logged in user. If you have to, so you will expand these as needed to match your domain. In my case, I would have like a landing page when the person's logged in, they have their profile. When they're logged out, it might be like, oh, thank you for using whatever, or something like that. So it depends on like how you model your application. That's kind of the point, right? Like all these choices I made here, they're not set in stone. This is just how I imagine my landing page would look like and what things are meaningful to me in my landing page. Doing this is just making sure that like in states where things are not meaningful or relevant or possible, they're not like carried along. It's like a clear separation. The things I need when I need them, and when I don't need them, they shouldn't be there. This logged in user data, if I'm not logged in, it should be there, yeah, I don't know. I hope that kind of answered that. But yeah, I made this choice because in my head, I would sort of do different things depending on which one of these had happened. And that's it for the slides. So now I am going to.
Kirk, we had one final question.
Oh yeah, sure.
About on that last slide. Just like, what does the object look like? What does the landing page object look like that has that type? I don't know if I said that the right way. What does an object of type landing page look like in JavaScript or in TypeScript? But like, what does the actual thing look like?
Hold on, let me play again. So when I think of something like this, this was Christopher that asked this question, right?
Oh, this is Carolyn.
Carolyn, okay. Hey, Carolyn. When I think of something like this, I'm usually thinking of something like a React app, something where you have some representation of like the state of your application. So when I say landing page, this object would represent like all the pieces of state on the page that I would care about. I mean, this is like a truncated example. Like general page data would have whatever I needed, like buttons or like any information that like might change. So a valid version of this, and like, landing page state right now could be viewport size 640, 480, dark mode false, and then the user status not signed in. It's like, okay, this is the info I need to render my page. But at a different point in time, someone's logged in. If the person's logged in, this general page data is always here, right? Because general page data and user status. So this is still here. But now my user status is now a logged in user. I have a username, I have our char strings, I have whatever list of contacts, whatever data I need to render that page. So that's like the context for a data structure like this. It's like, what's the state I need to keep track of when people visit my page in something like React or Vue or Elm or any of those types of frameworks. Yeah, later on, I can. Yeah, go ahead.
I was just gonna say, so like an object of type landing page, does it have a key of general page data, or like do they get, or does it just have a key
Oh, I get what you're saying.
and a key of username?
Yes,
you know what I mean?
yes, yeah. It's gonna combine the objects as if they were just like one. Yeah. So the final object will have, yes, sorry, I get what you mean now. It will have a viewport, a dark mode, a username. That's exactly what it will do. Yeah.
Excuse me, Kirk, but how would it be possible to have a node signed in and logged out inside the object? That was more my question.
Ah, I see. The answer is I messed up. Yeah, these, if I was going to use this like this, I actually would wrap these in like a similar object data structure, maybe something like value, just so I could pull them out. Yeah, no, that's a good catch. As it is right now, it wouldn't be addable. I would have to put them in like objects like before. Thank you for that. That's a good catch. That's danger.
One more question from Travis.
Sure.
If this were code, you would be, I'm just going to read it straight up. If this were code, you would be calling user status lexically, I never said that word out loud. You would be calling it prior to it being defined. Are types automatically elevated to the top of a scope, like in a function declaration?
Yes. Yeah. So yeah. So it's yes, to answer your question. The answer is yes. As long as like they exist at compile time, the compiler will make sure that all is. Yeah. Cool. Thank you for the questions. And now I'm just gonna like jump into some like real examples. I've been talking for so long, so I'm gonna try and like do this quickly, just to show you what's happening. But I'm just like hoping people kind of get like the point of these. Yeah, and this should kind of clarify some stuff. So first, we are doing form validation, classic. So we're doing like the HTML5 version. So we've got like some required fields and required fields. Like we're using HTML to help us with the form validation, but there's one problem with HTML5, like doing the validation in HTML5, which is for things like passwords. You can use a regex to check to see if the password matches, but like all it will tell you is bad match or accepted. It won't tell you like what's missing from your password. And we would like it to tell us like what's missing, like, oh, didn't put a number, your password is too short, like these types of like helpful hints for a user. So here, let's see if this works. Oh, let me hide the meeting controls again. So I literally have to type the password because I told it to, and I'm regretting the decisions of earlier, Kirk. But so I can do this, I can hit submit, and it's like, hey, the password's too short, password needs at least one, it's got all the cool stuff, and like if I add this, it's like, oh, okay. If I add a capital letter, we can do that. If I add, so it's doing its thing. Cool. So here's the first version of this, which is the sort of like way I would write this in JavaScript, or way it's typically written in JavaScript. And we're gonna have to like work our way up because you have to put like, you need to call stuff that's already been defined. It doesn't work for functions like it works for types. So we have this document, we get the new user form, we add the event listener, validate the form. Our validation logic, hey, let's get the value in the email field, get the value in the password field. We have this function, get password errors. We pass the password input, it gives us back a list of errors. If the list is empty, we send it to server from this mock server API thing. And if it's not, like, or otherwise, like update the errors. And if we go up here, update error is basically just like makes a new like list and sticks it on the page. And then here's like the real like meat of this part, right? Get password error. So it takes an input string and it does all the checks. Hey, if the length is less than 8, password is too short. If it's, it passes the strings in, and that's it. So this is fine. Like this is fine. This works. It's fine. The only issues or like the only things about this, about doing some TypeScript, is just like I would like try and take advantage of TypeScript features. Here we don't really get that much help from the compiler. Like we could pass in any string and it would attach it to this, right? So in case we ever made a mistake, like we wouldn't catch that. The validation, like there's no checks here for if we make any mistakes. It just kind of runs, and that's a little unwieldy. And I don't know, this is like a personal thing for me, but it takes me a while to kind of get situated in modules like this, to kind of figure out like what's going on in this module, where am I supposed to be going, like what is this thing trying to do? So let's look at an alternate version. So this is sort of the way I would do this in TypeScript. So the first thing I would establish, like, okay, what do I care about? What's my valid data type? And it's like this idea of we're getting these credentials. So a credential is an email and a password. And instead of using the raw strings, we're going to make these types called email and password, because not all strings are valid emails, not all strings are valid passwords. Here we're using our branded types, emails, type email. So it's enclosing a string, but like it's different from a string because we want to do some validation. Same thing for password. And I've made these parse errors. Like, what are the errors I can get? Well, too short, or there's no capitals, or there's no numbers. And then finally, I didn't have a chance to get too much, I made this thing called the result type, which is parameterized. We're not going to get too much into it, but basically we're saying, hey, we're either going to get the type of the thing we want back, or we're going to get a list of parse errors. And this is like abstract, so we can use this of, kind of whatever type we want to check. So now we have try email, you give it a string, and it makes a result. We have try password, again, takes a string, returns a result, because we don't know if the string we got in is valid or not. So we're actually going to like return something that checks like, hey, either this is the thing I want, or it's a bunch of errors. So here, like it's doing the same validation, but notice we're pushing the things we defined from our parse error type. And let's say I accidentally did something like this. The compiler would not like that. See, like, we get an error. Argument of type too short is not assignable to parameter of type parse error, right? So immediately you can only push things to this list that are of the right type. So that type of mistake just like cannot happen, which is great. And yeah, so our try credentials function, takes the strings, tries to make them, does the checks. Hey, if they're okay, you can return these things. If they're not okay, then you can return error basically. And here we have error to string. I take a parse error, and this is where I translate it into the string I want. So this is like really important, and like the general workflow, you want to get out of the realm of primitive types as quickly as possible in your application. You usually hear people say like validate early, but in this case, it's like parse early. As quickly as possible, go from whatever random input is coming in into some meaningful data structure. Because once you're in there, you can always get back out. Yeah, so we have error to HTML. So again, I'm not taking in a string, I'm taking in the parse errors. I'm taking in the parse error that I know is defined. Okay, let's make a new list object. Let's convert it to a string. Let's return it back out. Yeah, and that's it. So like this is just like my version of it. And I guess the final thing is the function that actually sends it to the server. I'm not going to make it just take any random object. I'm going to make it take credentials. So credentials is always an email and a password, and those are always like validated. So I can do creds email.value, and I can know by the time I get here that this has already been validated. Because to make credentials, you have to go through the validation function, and that's like cool. So a couple things about this. this is more code than the first version by far. But in my head, and like to me, it's not necessarily like harder to read because again, immediately we have like the context for what this file is trying to do. As soon as you open up this file, it's like, oh, there's credentials, there's an email, there's a password, there's these errors. Like I know what the purpose of these things are. And then in my functions, again, they're clear on what they're doing. Oh, try password takes a string and returns like the result, like a password result, try email does the same thing. Try credentials, like you can read functions, the signatures, and know what they're doing and not necessarily have to like dive into the code to figure it out. So that one, that's like the first example of like how you would kind of use branded types for validation. And very quickly, because we're running out of time, we have this one. Hey, we're getting Pokemon. So this is the world's smallest React app, and it combines the only two things that, my two interests, writing code and Pokemon. You hit randomize, it gets a random Pokemon from the Pokemon API. Fun fact, there's a Pokemon API, and if I had known that 10 years ago, I would have wasted all my time. So it does this, we're getting stuff. This is a great time to give a shout out to Dan, because Dan helped me put this one together. So let's look at sort of the way you would do this in JavaScript. So we have this get random ID. Ultimately, the way the API works is we pass in an ID representing the number of the Pokemon, and it sends us back some content. And this is React. So we have our initial state here. So get random ID, we have whether it's loading or not, and we have the data. So our initially, we have no data, it's initialized as null, we're not loading anything. And we have this function that actually fetches the Pokemon. We have our reducer for our React app that says, hey, what to do, what type of action is happening. Did we start loading? Did we finish loading? Are we randomizing? And then here's our app itself. We have our effect that does the fetching, and we have our view. And our view says, hey, if the state is loading, show loading. If we have data and it's not null, show the data. And again, this is good. Like this works. Like this does everything we need it to do. Let's just like look at the alternative version. If I were doing this in TypeScript as opposed to JavaScript, how would I structure this? So here's how I would do the TypeScript version. Again, what are the data structures that matter to me? So the way I see it, there's three things we could be doing, right? Like either the app just started, or we're loading the fetch, like you sent the request, or we have a fetched Pokemon. And if we have a fetched Pokemon, well, what are we kind of getting there? Well, the type is fetched, so we make this branded type. The value is string. String represents the like image source. So it's like if the app just started, we haven't fetched the Pokemon yet, we shouldn't have any of this. If it's loading, we're in the process, we still shouldn't have any of this. Once we get the response back, this is what should be there. And then we also define like, well, hey, how does our app transition? It turns out there's only like two actions really happening in this app. Either like we're requesting a random Pokemon, or the API is returning the Pokemon that it got. And I guess a couple things I want to show you. So our reducer has shrunk a ton, right? And we're just switching on the action type. So like, hey, if the action type is random Pokemon requested, then change the loading, because now we're loading it. If we got the Pokemon back, return this. Now here we're saying, hey, give me back the action value, because up here we said, hey, it's a Pokemon returned. Not only does it have a type, it has a value. But the super cool thing here is that we can only access this on this version of the case statement. I can't do it here because this type doesn't have a value attribute. If we even tried to like do something with it, the compiler would be like, hey, whoa, buddy, hold your horses, is what I say. Hopefully it actually like demonstrates that I'm not lying. I might have to refresh the page. Oh, there we go. Haha, it worked. I told you. So property value does not exist on random Pokemon requested, right? So like the compiler understands that these types are different and it knows the attributes in the different types. So if you try and use the wrong one at the wrong time, it will tell you that before you, like the code won't compile yet. So you can't accidentally like call things in states where they don't exist, which is super cool. But if you are in the right state, it gets it and you have access to it, and that's super cool. So for the rendering, we like made this little create component, and we're doing it again, right? Hey, if the state is loading, we're in return loading. If the state is initial, return an empty div. If the state is not loading or initial, the compiler understands, well, we must have fetched the Pokemon, which means we have a value. So in the same way, we can only access this value in the states where like that value exists. And then in our default app, so our use effect, if you're in the state of initial or loading, fetch the Pokemon. If we've already fetched it, then we can't, like it doesn't run this function. And yeah, that's kind of like how I would do that. So just to recap, primitive types are great, but primitive types are flawed. They are very, very general, and so rarely is real life actually a string or a number. The domains that we deal with as programmers are more complex than that. So when you have a language that lets you like easily represent that complexity, I think it's a very powerful thing. TypeScript has a really powerful expressive type system that lets us do this. And the moral of the story is like, you can do this, like JavaScript has classes, and you can kind of make classes do this too, but it's a lot more verbose and it takes a lot more like effort and boilerplate, which is why we don't typically make these types of things in JavaScript. It's not that we can't, but like it's just like way more words to write and it's a lot harder to read. In TypeScript, it's really easy to just kind of say what things are, and then the compiler will help you. So, you know, if you're using TypeScript and when you're writing TypeScript code, I just encourage you to hey, take some time and like, hey, what's the valid data structure for what I'm working in? You know, what are my inputs? How do I translate them into the appropriate structures? And then when I need back outputs, I translate them back. I tend to spend a lot of time like thinking about the types, and once I get the types right, the functions are just the functions are just like mappings, right? I just need to get from this type to this type. So you're moving from a action-oriented, function-oriented way of programming to a data structure type way of programming. And I think that it's pretty cool. And you get like code as documentation, and you get the compiler making sure that you don't mess up, right? I can't even set this initial state to the wrong thing because the compiler will be like, hey, you're a liar, you know, and we don't want to be liars. And yeah, that's it. It's a presentation.
Thank you, Kirk. We have a few questions. I actually have one of my own, and it might be a weird one to try to explain, but I'll try to work through it. If you can scroll down to your reducer, you're switching on the, like action.type, which is not like a TypeScript type, right? That's just like a parameter. It could be like switch on
It's
action type. But what I was wondering is, can you could you switch on the type, like the TypeScript type? Like it basically, like if you have a variable, are you able to identify what like?
Yes, you absolutely can. Yeah. The reason why I mean, so this is, a lot of people use this pattern with reducers, like for the actions, like making it be the type of the action and then like whatever payload it needs. But yeah, you can just reduce on the type itself. Like, so the power of these, and you notice like I'm using switch statements versus if statements. And the magic is, if you're using switch statements on union types, you don't have to provide like defaults. Like switch will check to make sure like you've covered all your bases. So if we only did one case here, not the other, like it would complain like, hey, there's actually 2 valid versions of this action, but you only did one. But once we've covered the 2 valid versions, you don't need to provide a default, because literally the only thing this can accept is an action. So there's no need to put like oh, well, what if it's something else? Like, because it won't let you pass in something else. But yeah, if we wanted to, we could have just pattern matched on the type itself or some other value. You can choose whatever you like.
Nice. That's pretty cool. Travis was wondering if TypeScript types can include bounding. So like, this is gonna be hard to
Oh,
like actually say out loud, but like for a number, like can a can you say a type is a number like greater than 0 and less than 4,000 or whatever? For
ooh,
instance.
you, Travis, it's a massive can of worms. The answer is sort of. So that thing you call bounding is called sort of like dependent types in type theory, and it's actually a really rare thing. It turns out it's pretty like it's a pretty complex thing to do. Haskell has a proposal to add dependent types. As far as I know right now, only like Idris and a couple other like really high level functional programming languages have that type of thing. So what I would typically do, like for most cases, in that I'm just going to type stuff here. I would say like type some nums equals, and I would do like the bounded type thing, and it'll have like a value int, and then I would use like some sort of validation function to make sure they were right. But TypeScript does have some very, very advanced type stuff you can do. I didn't include it because I'm still like learning it, where you can say things like, oh, make this type, but at like check to see if the answer is yes, but like I don't know how to do it, or I don't know how to like show it in a way that makes sense. TypeScript is honestly like one of the more powerful type systems I've ever seen. But there's a lot in there that's like really, really esoteric. So, okay, I'm going to show you something you can do in TypeScript that kind of like blew my mind really quickly. So let's say you have a list type. No, we're going to say like a list. Const stuff equals, like thing, that thing too, or something like that. So we're just like making a regular list. What I've seen people do, I'm not complaining yet. What I've seen people do is you can do like something like this: type stuff is equal to oh, and for everybody else, this is like weird, gnarly, like extra cases. I don't like this is not a thing to kind of concern. I can't even do it. Okay, it's when I did the Roman numerals, there is a way you can take a list in TypeScript and you can tell TypeScript like, hey, turn this list of things into a type, and it will turn it into a union type. And I used it and it kind of blew my mind. But like that's like very high level stuff, which is I don't always like. You be very careful, that type of stuff. It's very easy to get confused. Anyway, to answer your original question, yeah, you can do that. Sorry.
Courtney had a very good suggestion, I think, for this. So if you have like a type of integer, between 1 and 4,000, you just say your type, and then it's 1 or 2 or 3 or 4.
Yes. So we saw the literal types with the strings. It also works for numbers. But yeah, like you could literally do 1 to 4,000, and that would absolutely work, Courtney.
I think it sounds perfectly valid.
I mean, I do it more often than you think, right? Like if I have a reasonable amount of a set of things, I'll just write them out, because why do all the like I can just literally write them out. But yeah, 4,000, you might want to have a different style.
Let's see here. Andrea was actually wondering how easy or hard it is to go from like nothing to starting to use TypeScript in a project.
Okay, this is I think a big cause of contention. So if you already have an existing JavaScript project, I think the mistake a lot of people make is they immediately like try to convert it all to TypeScript, and they turn the compiler on at max, and that will drive you off the wall, because most likely you will get so many like type errors, not from your syntax being wrong, but like TypeScript hates ambiguity, and most JavaScript like is like there's no type information, right? It's just like super ambiguous. So what I would suggest, and the general suggested thing, if you're going to start integrating TypeScript into your project, is to start like one file at a time. Just change like one file to TypeScript, and the types the compiler's going to do its thing. It's going to tell you all the places where like, hey, this could be wrong. This could be an error. You slowly work your way through that. Also, the compiler has settings, so you can tell it how strict you want it to be. So some people start off on like less strict settings and work their way up. It's kind of up to you how you would approach it, and like it depends on the size of the project I'm working with how I would do it. But what I don't suggest is if you have any meaningful amount of code, just immediately like going full force. All this is now like .ts files. That's probably going to drive you off the wall. One function at a time. But if you do that, it's not too bad because again, JavaScript is valid TypeScript. You're just usually adding information. So step one, just add type info, and then step two, you can start like refactoring and so yeah, I like it clearly. So yeah, I have these are like I'll share links. I don't know if you share them, Dan, to like these code sandboxes. I also have these on GitHub, so if anybody wants to like use this code and poke around with it, it's all there, and you can totally get a look at that. Also, we do the code challenges every 2 weeks. This is how I pretty much write all my code. So if anybody wants to see like, oh, what would be the TypeScript implementation of some of those, you can let me know. Yeah. I'm gonna stop sharing now.
Thank you so much, Kirk. Do we have any other final questions or comments, before we wrap up? I'm just gonna like ramble for a couple minutes. So if anybody has any questions they think of, just let me know. Or if I missed anything in the comments, I was trying to keep an eye on, but it's easily possible. I just totally missed somebody's question. But yeah, Travis, what's up?
I was just gonna say, earlier on, Kirk said TypeScript is very well supported in VS Code because VS Code is written in TypeScript. He's totally right. There's some really cool kind of built-in functionality for JavaScript and TypeScript in VS Code. So if you want to play around with it, there's some really cool stuff that VS Code can do that you can't really find in other interpreters. One of which is kind of how I started feeling out TypeScript. I started adding, I wrote it in chat, but commented out @TS-check at the top of a JavaScript file, and the VS Code program will start running TypeScript checking on a JavaScript file. So you can, and it won't break anything. It'll just kind of put the red squiggly lines under things as if it was a TypeScript file. It won't stop you from doing anything, but you can sort of start using that like training wheels where you sort of start seeing where the compiler might have issues and that type of thing. I thought that was really fun and interesting to do. Of course, people are going to start asking why that is at the top of all of your JavaScript files, but you can always go into that explanation. But yeah, that's a cool kind of half step to start playing around with it.
Yeah, I think that's a really cool tip. Thank you, Travis. Colin, you had your hand up. What's up?
Yes, it looks like there's no strong relationship between TypeScript and functional programming, but I also know you're into functional programming. Or what is the relationship? I mean, I guess one thing they have in common might be that the compiler can catch stuff that that's true for both types of programming. Compiler can catch things that normally you'd only catch during runtime, but any other?
I mean, I would. That's the thing. Like, TypeScript is defined as multi-paradigm. So yeah, there's lots of things about it that are very functional. Like this type of type system is absolutely something you see like every like functional language. So I was really surprised and excited when I saw it in TypeScript, because TypeScript is also object oriented. I didn't show any examples, but you can write like TypeScript has full support for classes and like strong classes. So with encapsulation and polymorphism and all that fun stuff, you could absolutely, and a lot of the things I did here, traditionally, you would do them using class structures. But the nice thing about TypeScript is you don't have to reach for something as like as heavy as a class. You can just use these types. But yeah, so I would say it's both. It has functional elements and it has OOP elements. But you probably wouldn't call it a like a pure functional programming language, because stuff like currying and a couple of the other things are not there.
But would you say classes is goes against functional programming?
Traditionally, yes, because ultimately, like the core concept of classes is that and you're saying like there is an object that changes state, and functional programming says like everything's immutable, like things do not change state. So just like the idea of having like an instance of the thing and then like changing an attribute is something that just like does not exist. It's like everything we saw here is just like pure data, right? Like all the functions take in a data structure and like return another data structure. The data itself, it doesn't have any methods, like it's just a piece of data. Yeah, so classes, and I mean, I don't know, at the end of it all, anything I can do with a class, I can do with a module and vice versa. So I'm not like, no, classes are bad. You know, I use classes when I do them. And TypeScript gives you the option. Use the thing that like makes sense. But I just tend to lean for, I will use functional solutions until like there's a very good use case for introducing like state in a class. Matt's got a question.
It's not a question as much as more of a comment, but I'll post a link in here. But I do most of my coding in Kotlin, which is like a JVM language. But I am seeing a lot of similarities in just kind of the direction the language is moving to some of the type stuff that you talked about today. So I posted a link to this thing that's still in beta. It's called Inline Classes, but it's essentially like a way to give you the power of like having a more semantic type defined without like the performance overhead of boxing it in like a class. So it's a way to kind of represent or pass around a primitive type, but it has a stronger type safety, similar to kind of the examples you were showing earlier. So
yeah, I think that the general trend of sort of the languages made in the last 10 years is they have this like hybrid style approach. You know, you still need support for the old school style of like OOP all the things, but you don't have to OOP all the things, especially when you just like want like a solid data structure and you don't want like, because classes, depending on the implementation, can come with like a ton of stuff under the hood that just could be not useful or relevant. So yeah. I should check that. Kotlin's another one I wanted to check out a lot, so I'll probably look around for it soon too. I like languages.
Yeah. All right. Well, if nobody else has any questions or anything, I think we'll wrap up. Thank you so much to Kirk. I mean, I think this was really awesome. I enjoyed it very much and learned a lot. I still haven't really taken the TypeScript dive yet, so I appreciate learning from Kirk as always. Feel free to follow up in the Brownbag channel in the Slack if anybody has any follow-ups, questions. I'm sure Kirk will post the links to the different resources and maybe the slides or whatever. And otherwise, we will catch up with everybody on Tuesday, I guess. Well, we got Rahat's Brownbag on Monday and then coffee on the normally scheduled coffee on Tuesday. So if there's nothing else, then thank you very much, and we'll see you guys later. Bye.